So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic production and propagation of waves. So in short, to stay to the end of this video, guys, let's go ahead and start with the first question here. It says, determine the value of the amplitude and wavelength respectively of the wave. So now guys, for this particular wave, we can see that here we have 16 and over here we have 27. On the y-axis we have 16 and then on the x-axis we have 27. Well, so guys, let's recall that the amplitude of a wave is the maximum displacement of that wave. Now, so since the amplitude of this wave is the maximum displacement of the wave, we are going to have that the amplitude here is 16/2, and that's 8 cm. So whereas for us to calculate the wavelength, let's note that here we have the length of this wave on the x-axis here is 27 cm. So but then the wavelength is going to be this 27 divided by the number of complete cycles we have here. So we have 3 complete cycles here. So in that case, this will be 27/3 and that's 9. So guys, the amplitude of this wave is 8 cm, whereas the wavelength is 9 cm. So that's option D here. Let's try it and consider the next question, guys. So the next question we have here, question number 2 says, a progressive wave has a wavelength 50 cm. Calculate the phase difference between 2 points at a distance of 20 cm apart. So here we're going to have the phase difference, delta phi, to be 2 pi delta x all over lambda. So guys, for this here, we're going to have that the 2 times pi times delta x is the difference between the distance. So the distance apart here is 20 cm. So in that case, this will be 2 pi 20/50. So 2 pi times 20/50. So in that case, that will be 40 pi/50. So that's 4/5 pi. So guys, the phase difference here is 4/5 pi, and that's option C. So let's go ahead and consider the next question, guys. So the next question we have here is question number 3. It says, the amplitude of a wave is the A, distance traveled by the wave in a complete cycle of its motion, B, distance between 2 successive troughs of the wave, C, separation of 2 adjacent particles vibrating in a phase, D, maximum displacement of the wave particle from the equilibrium position. So guys, the answer to this question is option D here, the maximum displacement of the wave particle from the equilibrium position, that's from the center. So let's go ahead and consider the next question. So guys, that's question number 4 here. It says, which of the following statements about distance and displacement is not correct? A, distance has dimension L. B, displacement is a vector quantity. C, displacement is measured in meters. D, distance is a vector quantity. So guys, the answer to this question is option D here. Distance is actually not a vector quantity. Rather, distance is a scalar quantity. Distance actually has no direction, and as such, option D is the answer to this question. Let's go ahead and consider the next question, guys. So here is the question. The diagram above illustrates a waveform. Which of the points in the waveform are in phase? So guys, the points that are in phase here in this waveform are points P and T. So that's it for this question. So points P and T are in phase, and that's because the angular displacement between P and T is 2 pi. So that's why we have both of them as in phase. So this is 2 pi. That's the angular displacement between P and T. So 2 points are in phase if the angular displacement between them is equal to 2 pi. So let's go ahead and consider the next question, guys. So the question we have here, question number 6, it says, the diagram above represents the displacement d versus time t graph of a progressive wave. Deduce the frequency of the wave. Alright, so guys, this is just simple. When you have one complete cycle of the wave, that's the points here having 0.1 seconds as in time here. So it means that it takes 0.1 seconds to complete one cycle of this wave. So in that case, the frequency of the wave will be 1 over the period. That's 1 over 0.1, and that will give us 10. So option A is the answer to this question. Let's go ahead and consider the next question, guys. So that's question number 7 here. It says, the inverse of the time required for a wave to complete one full cycle is called a period. Actually, guys, this is the answer to this question, period. So let's go ahead and consider the next question. So the next question here is question number 8. It says, a rotating disc contains sets of holes in a cycle. An air jet is directed into the holes and a note of frequency 480 Hz is produced. If the number of holes is 20, calculate the speed of rotation of the disc. Alright, so guys, for this question, let's take note that we are calculating the speed of rotation, and here we are looking at the speed of rotation in revolutions per second. So that's the number of revolutions per time here. So in that case, let's take note that the frequency F is equal to number of revolutions times number of holes over the time period. So guys, in this case, the frequency 480 Hz, and then the number of holes is given as 20, and then the time is not given, but then also the number of revolutions is not given. But let's recall that number of revolution over time here is actually the speed of the rotation. So guys, in that case, we are going to have that 480 Hz is equal to number of rotation and n sub r over the time t, then times the number of holes, that's n sub h. So guys, that will be that number of rotation over the time is equal to the frequency 480 Hz over the 20 Hz. So guys, that's 24 revolutions per second. That's option A here, guys. Let's go ahead and consider the next question. So the next question here is question number 9. It says, in the wave frequency y is equal to E naught sine into 200t minus pi x. E naught represents the A amplitude, B wavelength, C frequency, D period. So guys, the answer to this question is option A, that's the amplitude. So E naught here represents the amplitude. Let's go ahead and consider the next and last question, guys. So the next and the last question here is question number 10. It says, which of the following waves requires a material medium for its propagation? We have A, sound wave, B, radio waves, C, light waves, D, X-rays. So guys, the answer to this question is option A, that's the sound waves. So that's it for this question. And sound wave is actually a mechanical wave, so it actually requires a material medium for its propagation, whereas the other ones here are actually electromagnetic waves and therefore do not require material mediums for their propagations. So guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section below and we'll ensure to give you a response. So finally guys, we want to encourage you to join our YouTube channel community. You can join this channel community by hitting the join button below and we'll see you right there. Thank you once again for watching this video. See you on the next one.